hopefully this can be visible there. What is this? Well, what choice now do I have here? Well, of course, this number can't be a 1. It can't be a 2, because if it were a 2, I would have order pair 2, 2, and I'm specifically constructing this to be orthogonal to this one. But it also can't be a 3, because if it were a 3, then I would have order pair 3, 3. But now these two Latin squares need to be orthogonal to each other, and I already have an order pair 3, 3, so this would have to be this can't be a 3, so it's got to be a 4. Okay, and now a lot of the same logic kind of repeats, but now I get to force this to be mutually orthogonal to this one and this one, and let's see how I do that. Well, I don't know. Let's see. What goes? Now I think maybe we go here. So this seemingly could be a 3 or a 4, but actually it can't be a 3 because that would be 3, 3. So it's got to be a 1, and so that has to be a 3. And now going here, this could be a 1 or a 3, but if it were a 1, then I would have 1, 1. That doesn't work, so it has to be a 3. And here I would have to have a zoned out. This can't be a 4 because that would repeat. So this has to be a 2, 3, 4, 2, 3, 1, 4, 1, 4. Oh, just horrific embarrassment there. That has to be that of course has to be a 2. Why did I say 1? This can't be a. This could be either 2 or 3, but if it were a 3, it would be a problem. So it has to be a 2 instead. Yeah. Okay. Sorry. Here now, what can this be? 1 or 4, but it can't be a 4 because that would be a repeat 4, 4. So that's 1, and now 4, and now, oh my god, can we please be done? What goes here? It could be a 1 or a 2, but if it's a 1, that's bad because 1 repeats, so it has to be 2, 1. What could go here has to be a 4 now, 1, and that has to be 2, and that has to be 3. Okay, so I think I did that. I've certainly forced it, well, it's now, I guess, maybe not so totally obvious that these are mutually orthogonal, but they are. And now using these for mutually orthogonal, is it worth maybe sort of checking that they're mutually orthogonal in some kind of way? Maybe we'll just do it in for one of the numbers, like take the 1s. The 1s go along this column, and so, well, here the numbers each appear once. And here, here the numbers also each appear exactly once, and those, well, what that really shows is that these two are mutually orthogonal, and these two are mutually orthogonal. I guess what's less clear is that the second, and at least with respect to the 1s, what's less clear is that the second and third should be mutually orthogonal. For that, we would need to circle all the 1s here, which appear in these positions. And now to circle those same positions, and what do we see? 1, 2, 3, 4. So at least for the 1s, that shows that the second and third are mutually orthogonal. But at the moment, I haven't given any explanation for why we should be confident that these are. But I did sort of do my best, and it worked. All right. What was the whole point of all this? The whole point of all this was if I have access to these, then I can just go straight by expanding my answer to problem 12. I can now take my 4 kinds of detergent, my 4 cleaning tasks, but now I am going to explain how to run this experiment in a fair way, and my explanation is going to say that, all right, in each of these 16 runs, in which you run each detergent relative to each cleaning task, match the water hardness and washing machine brands in the following manner. Well, first, let it be a sorry, now I lost my train of thought again. Have I missed something here? Also, just one of these 4 different. They also use 4 different brands of washing machine and the water hardness. So washing machine, and now we're also going to do water hardness. So am I crazy that 1, 2, 3, 4, 4, 3, 2, 1 that I didn't even need? I believe I didn't even need 3 mutually orthogonal Latin squares. I believe that I only needed 2. So I'm going to use this one and this one, but in fact, unless I'm mistaken, it's very late at night, but I think now using this Latin square as inspiration, but matching w with 1, x with 2, y with 3, and z with 4, I shall now fill in, well, w, x, y, z. Here, this is x, oh my god, x1 is w, z, y, and here, for some reason this is confusing me, y, z, w, x, and here, z, y, x, w. This is just simply what I've done. Everything looks good. And now, built into this experiment is how to introduce water hardness. Yeah, I think I'm just right about this. And how should we introduce water hardness? Well, I will now just take the entries from this Latin square. 1, 2, 3, 4, 4, 3, 2, 1, 2, 1, 4, 3, and 3, 4, 1, 2. So, okay, I would love another human being to confirm this to me live on the spot. But what I think is, well, okay, clearly this is a Latin square, and so is this. And so certainly every brand of detergent is being matched with every kind of cleaning task. Every washing machine, because this Latin square, because this is a Latin square, every washing machine type is being tested once with every different kind of cleaning task, and because the columns of this are a Latin square, because this Latin square has the column property, it means that w, x, y, and z appears once in every column, which is to say that every kind of detergent is matched with every washing machine. Additionally, because this is a Latin square, that means that because of the row property, that 1, 2, 3, 4 appears in every row, it means that every type of water hardness is being tested with respect at least once to every different kind of, exactly once, with every different kind of cleaning task. And because of the column property of this Latin square, every number which represents water hardness appears once in every column, and that means that every column here contains a 1, 2, and a 3, and a 4, which means that every type of water hardness is being tested with every single type of detergent. But what's interesting about this problem is that Gossett could have taken it one step further, and he could have introduced some, if I'm not mistaken, he could have introduced some even extra thing. I have no idea. Well, temperature, say, like we did in the lecture. We can now have temperatures like cold, lukewarm, warm, and hot. And because of this third mutually orthogonal Latin square, I could once again introduce one more variable such that every two are tested with respect to each other. And I guess the last thing I should say is that because these two are mutually orthogonal by construction, then built into this testing regime is in fact that every washing machine is going to be tested with every kind of water hardness. That's kind of the point, which is to say that none of these ordered pairs repeat. Okay, so good. So I think that gives you a sense of how powerful these Latin squares are. You would think that this would require. Well, I'll stop there. Okay. Seemingly 4 to the 4th. Which would be 256 different tests to test every single one of these. Okay, I'll stop there. All right, this was the homework on Latin squares. How long did it take? Oh yeah.